Assalamualaikum. My name is Nur Nadira Fakia binti Zulkifli, and today I will be presenting about the assessment tool for group project, and my members will be Muhammad Danish bin Muhammad Fauzi and Dini Aiman Syahmi bin Cik Azman. For task 1, I will be doing the task 1. So in task 1, the data was taken from the official website of Full Stock Market. This document provides an analysis of the gold market as of December 2023, highlighting the current trends and significant changes over the past 5 years. So the price of the gold from the February 2025 is listed at $2,654.90, representing an increase of 75.40% since December 2019. Additionally, this chart discusses the day and 52 weeks trading range as well as open interest in gold contracts, illustrating the volatility in investor interest in this precious metal. Based on the current trends and historical data, gold price are expected to continue their upward trajectory over the next 5 years. So, for the first step, from the given link in Figure 1, fill up Table 1 with related value by assuming the data represent the closing value taken at the end of the month for every 6 months or biannually. So, from this link, I will get the data for this month, and this is the data that I got from the link, which is from month 1 to month 16, 60, the data collected for the gold data closing value in USD. For the first month will be 1,574.30 until the 60th month will be 2,657. So from this data, we will find the Lagrange interpolating polynomial for the given value in table 1 in A. Hence, use the polynomial to approximate y equals to fx for September 15, 2023. Firstly, we will do the Lagrange interpolating polynomial n plus 1 equals to 11, n equals to 10. So from this n, we will know that there will be k equals to 0 until 10. So for the first one, k equals to 0. So in L not x, we will enter the value of 0 into this equation. And this is the final equation that we will get for the first one. And we will continue on doing it until k equals to 10. K equals to 10, and we will get the final equation for k equals to 10. Next, for the next step, we will find the pkx value, which is the equation that we get from the first part. We will need to multiply it with the value of the data that we get from this table. We will multiply each data with the equation that we got from earlier, and we will, when we multiply it, we will plus with the next data and the next one until we get the final data, final equation. And for question 1, September 15, 2023 is in month 46. So pk equals to 46. When we enter the value of 46 in the equation, so the final answer will be 1,463.20318. Next, for the next question, what are the expectations for gold prices in the next 2 years? So in the next 2 years, it will be 30 November 2026, which is month 84. So the PO, the value here will be 84. Same things to do. We substitute the value of the 84 in the equation, and the final answer we will get 7821664.28. And for the final equation, September 15, 2023 equals to sum equals to x minus mean over x. So when we substitute the value that we calculate from here, 1463.20318, we will get the final equation, final answer here, 0.24817. So in conclusion, the relative error in B1 is low because of the exact value and estimated value was slightly different. For B2, the accuracy value was not relevant since there is no closing value yet for the next year. The prediction for month 84 are highly unrealistic to polynomial overfitting. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Danish, and I will continue for answer for task 2, which is for least square approximation. So in this case, we are going to study about volume transaction for Tenaga Nasional Berhad stock. So the question asking for to construct a Newton finite divided differences for data of volume of transaction yearly from January 2015 until January 2024. And for the second question, need to calculate Newton forward divided polynomial for x not equal to 3, and third one, calculate Newton backward divided polynomial at x not equal to 7 for the Tenaga Nasional Berhad company. So for the answer, so this is our data for variable x. We we make it as year 1, 2, 3 until year 10. So we have 10 variable, and for our fx also have 10 data of volume yearly, which is f0, f1 until f9. So the first thing, we are going to calculate the first divided differences, which is, the formula is fn minus fn minus 1, or here a equal f1 minus s0 over s1 minus x0 to get the data of first divided differences. So we calculate all the data from this table, and then from this data we're going to calculate second divided differences, which is, the formula is the first divided table, which is b minus a over x2 minus x0 to get the second divided differences, and calculate the third divided differences, fourth divided differences, and fifth divided. So the result of our divided calculation will look like this here. So this is our final result and tabulated. So this is our variable x, this is variable y, our fx, and this is first divided, and second divided, third divided, fourth divided, and until fifth divided. So for the second question, asking to calculate the forward divided at x not equal to 3. So this is the forward divided, which is fx is equal to 11.38, first divided is 4.59, second divided is negative 5, third divided is 2.05167, fourth divided negative 0.33292, and fifth divided negative 0.13050. So from this data, we insert into the formula of p and x. So the n we replace to number 3. So the formula is this one. So we insert our data from the table and then calculate. So in this equation, to prove our equation is correct, supposedly we should get 11.38, but this one we didn't get it because of maybe error in calculation. So for the next question is to calculate the Newton backward for polynomial. So same as before, but this one we need to calculate at x not equal to 7, which is from the table. The backward is here, which is 7, 10.99 mega. Until the fifth divided, we take negative 0.39400 mega. Then we insert into our formula here, and then to prove the P7x is correct, so we replace the x, insert x into 7, and we get the same value as our fx, 10.99 mega. And then for the question B, refer to the same data and use least square to fit the exponential model y equal to a exponent bx. So first we need to linearize function of y equal to a exponent bx, and then we get ln y equal to ln a plus bx, and we let ln y equal to y, ln a equal to a naught, and b equal to a1, and we summarize into the equation y equal to a naught plus a1x, and we convert to metric form as displayed here, and we calculate the value of our variable, which is, we have 10 data of year, and our volume, which is fx, we assume as a y, and then we calculate the value of ln y and x multiply of ln y, and then we calculate the total here, and we get for ln y, which is 21.77361, and for total of x ln y is 106 and 62449. And then from that data we insert into our matrix, and then substitute and calculate our a naught, and then we convert it back into a naught, which is a naught equal to ln a, and then substitute, and we get our a value is 21.17328, and for b is equal to a1, so we just take the value of a1, insert back to our equation. So our final answer is 21.17328 exponent negative 0.15916x. And then next, for our case study 3, so the question is asking us to find the least square polynomial approximation of degree 2 that fit the given continuous function of x squared plus cos x. Is to state the general equation legendary polynomial of degree 2. So from this formula we get the fx is equal to a naught p naught x plus a1 p1x and a2 p2x, which is p naught x is equal to 1 and p1x is equal to x, and p2x is equal to 1 over 2 multiply 3x squared minus 1. So we get this final answer. And then for the second question, we need to identify the suitable linear transformation if necessary, which means the question has two variables, which is negative 1, 1, and the other one is 0, 4. So the 0, 4 was undefined as a continuous legend ray. So we need to convert our coordinate 0, 4 into negative 1, 1, which is using the formula let x equal to a t plus b, and calculate to get the value of a and b, and then insert it back into x equation, which is we get x equal to 2t plus 2, and we insert back into our fx, convert to ft, which is our final answer will be 430 plus 8t plus 4 plus cos 2t multiply cos t minus sin 2t and sin t. So for the next question, we need to find the polynomial on the interval, which is for the negative 1, coordinate negative 1, 1, we have no problem. We only use our same formula to insert, which is use the and calculate our a naught as ak equal to 2k plus 1 over 2 and Laplace integral yx dkx dx, and then we calculate all of this, and then we substitute into function of fx, and we get the final answer of 0.53474 x squared plus 0.99656. And then for the coordinate 0, 4, as we know, we need to convert first to coordinate negative 1, 1. Negative 1, 1. So for this equation, we need to also convert the p0 p naught t into p naught x into p naught t. So the function of ft will become a naught plus a1t plus a2 over 2 multiplied by 3 t square minus 1. And then we insert our data into our formula and calculate, and then we get ft is equal to negative 11.32055 t square plus 6.81228 t plus 9.91765. Thus, but we need to convert it back to from ft to fx. So from function ft, we need to let t equal to x minus 2 over 2. So we insert our function of t. So it becomes our fx will get the final answer of negative 2.83014 x squared plus 14.726669x minus 9.21518. So that's all from me. I will continue for case study 4.
Okay, my name is Dini Emerson, ladies and gentlemen. I will continue for the task 4. So for the task 4, it's all about 2-point and 3-point rules. As you can see here, the question is about the Bursa Malaysia website. It's about the block operation Berhad for the past 5 years. The data given the distribution of share about this data given. So the question A is about to extract the data. So that was the first question, and the B questions is given that value step size 2 and calculate the first derivative following using 2-point forward difference, 2-point backward difference. That is about using 3-point backward difference methods, and the fourth is about using 3-point central different methods. We go to the solution. Alright. Okay. So as we can see, the first question is about extracting the information. So the informations have been extracted as can be seen from this table. We took from the x equal to 0 till to x equal to 11. With the month interval is about 2. July 15 is month 1, and September 15 is month 3, and it's go on with the step size of 2. So that's the data that we can get. The second question is about given the hash value step size are 2, and we are asking to calculate the first derivative of fx at following value when the x equal to x5 and the x equal to 9. The first question is about using 2-point forward difference method. So when x equal to 5, the step size will be given is about 2. So we use the other formula, f derivative for the 2-point forward difference is about fx plus hash minus with fx divided by hash, where hash is the step size. So we just try to put all the value of x givens. We get f7 minus f5 divided by 2 in up we got negative 0.08000. So for the b, when the x equal to 9, we just try to put we try to substitute the given x and hash by using the formula. Then we got the final answer is 0.18255. Now that was about using the 2-point forward different methods. However, for this question 2 is about using the 2-point backwards different methods. So the formula is quite different. For the second one, the formula fx minus hash divided by hash is different compared to the first one. So we just only substitute the data from the x equal to 5 and step size 2, just like same. We get 0.12750. Whereas when the x equal to 9, we get the final answer is about negative 0.09255. So the third question is using the 3 points backward difference methods. So this question we have the same value of x and it's but different in terms of formula. So the formula is about to find the f derivative is equivalent gfx minus 4fx minus hash plus fx minus 2 hash divided by 2 hash. So we just only substitute the given value, and up to the answer we get is 0.24750. When the value of x equal to 9 with the same set size, we just substitute all the value. Then with the last answer we get is about negative 0.09883. This is the last question for this part. This question is to try to solve using the 3-point central difference method. The same value, x equal to 5, step size hash equal to 2, but different formula. For this case, formula is fx plus hash minus fx minus hash divided by 2 hash. So we substitute all the value given. And the last answer for x equal to 5 equal to 0.02375. As for the question B, when x equal to 9, we substitute all the value and we got the last answer is 0.04500. So I think that's all from us. Thank you for listening and hope you have a good day.